This is Devin. I'm an intern in CCAS on the Digital Intern Project. And for our project, we are doing an LCA of disposable diapers versus reusable diapers. Now, our objective was to use Dayrise, but I thought it would be nice to validate the scores or the footprints we got against OpenLCA, which is a software I'm familiar with. Now, with OpenLCA, I have access to EcoInvent through an educational license, so this is a really great method to see how the carbon footprints between Dayrise and EcoInvent line up. So what we have here is just the LCA of the disposable diapers. And everything we did with the Dayrise LCA is the same. So the same system boundary, the same functional unit. We're using a 136 pack size 3 Huggies disposable diapers, and we're only doing cradle to door. So only the raw materials, the production energy, and the transport to consumer. So everything I inputted in Dayrise is the same as it is here. So just to walk us through it, here is the main production process. And fortunately with EcoInvent, you can just link a bunch of the materials that are contained in the diaper and it automatically calculates the carbon footprint. So here I just inputted the weight, unit, and then market for that good, which also includes the transport to that facility. The only thing that wasn't in EcoInvent, well, actually there's two things. One was the wood pulp. I had to use sulfite pulp as a substitute, and then also the sodium polyacrylate. So for the sodium polyacrylate, or SAP, I had to make my own production process. And to do that, I followed this scientific paper that has all the inputs for producing 1 kilogram of sodium acrylate or polyacrylate. So all these values here, I just took into OpenLCA, created a process, and inputted those materials. So that was how I was able to add 1 kilogram of SAP into my life cycle analysis of the diaper. And I'll come back to this later since there's an interesting comparison between this calculation for SAP versus Dayrise. Now going back to the main life cycle, again, we have all the materials here, including the electricity and energy use, and the packaging as well. Once we have the production of the diaper, we move on to the transport to LA, which is the final step in this shortened LCA. So here it's just inputting the distance that I found via Google Maps between our production facility in Texas to our customer who's located in Los Angeles. So that's what's modeled here. All right, now enough with the individual processes, let's go into the results. So just to show what I did in OpenLCA, I created a product system and I modeled the life cycle cradle to door of these diapers. So you can see here my diaper materials process is linked, which contains all these different materials from EcoInvent along with this process I created for SAP here. So looks good. So we'll jump into the analysis. So I'll just quickly run the calculation here. We're using CML 2001 as our impact assessment method, and I'll go ahead and run this. And I realize now I actually have it open up here, so kind of redundant, but just to show you how it looks like in OpenLCA. Okay, cool. So we'll just go straight into the carbon footprint and ignore the other impact categories. And we're doing global warming potential over 100 years, which is the standard. Okay, as you can see here, the total carbon footprint of 136 disposable diapers, including packaging, is 21.46 kilograms. And that's about, I believe, let me check here. That's about 158 grams of CO2 per diaper. I'll come back to this comparison afterwards, but I just wanted to show you what it looks like in OpenLCA. So if we open this up, we can see the breakdown. So it looks like around 33% comes from the production of the SAP, another 23% from the manufacturing process, the electricity required for that, another 10% from the wood pulp, and then finally another like 10% here for the final transport or delivery to the consumer. And then here's all the different carbon footprints for each step or material. Now going into the comparison. So before I go into the comparison, actually, I just want to point out something that was particularly interesting. So the sodium polyacrylate that I had to model in OpenLCA using the scientific literature, the value we got was 7.05 kilograms of CO2 for the production of SAP in 136 diapers. And what's actually very interesting is that Dayrise had a pretty good estimate for that. They had a 7.06 kilogram of CO2 impact for the sodium polyacrylate. So I can't speak really on the accuracy of this since we don't really know what the true impact is of SAP, but I can speak to the precision. And it looks like Dayrise and OpenLCA aligned quite well or were quite consistent in the value or contribution of SAP to the overall product carbon footprint. And that's super interesting because, again, SAP wasn't in the EcoInvent database. I had to model it myself, as you can see here. And somehow Dayrise was able to, model it or arrive to the same answer, which is pretty neat, I would say. However, when we go into the comparison of the other materials, we'll see some misalignment. So going into the comparison, the total carbon footprint, again, for OpenLCA was 21.46 kilograms, while the total carbon footprint for Dayrise was 23.77 kilograms. And again, this is for a 136 pack of disposable diapers with packaging. And so the percent difference relative to the OpenLCA product carbon footprint is around 11%. So that correlates to about 175 grams of CO2 per diaper for Dayrise and 158 grams of CO2 per diaper for OpenLCA. Now, going into the actual materials and processes, this is where things get interesting. As I mentioned here, the sodium polyacrylate is very similar, which is pretty impressive given that I had to model this myself, and Dayrise was also able to model it pretty much in the same manner, arrived at a similar answer. However, when we look at the other materials, polyethylene, there's like a 73.6% difference in the total carbon footprint that Dayrise got versus the value from OpenLCA. And I'll just reiterate that the OpenLCA models the product carbon footprint using EcoInvent data. So this is pulling directly from EcoInvent. So it should be the more, accurate number. So highly inaccurate here, I would say. But then everything else, it's mostly the same. Here it's like a 21% difference. Polyurethane, 21% difference. Cardboard box, 30% difference. Packaging for LDPE, 31%. Production energy, 14%. And then transport to consumers, around 20%. The polypropylene also was a little bit off, is around 100% difference. So there is something weird going on with Dayrise. For some reason, it's not getting the same carbon footprint for some of these materials. And really, we don't have any transparency into where Dayrise is getting this data. So we don't know if it's EcoInvent or something else, scientific papers, etc. So that's one of the downsides to Dayrise, is that there's a lack of transparency in where this data is coming from. In comparison with OpenLCA, fortunately, I have access to the EcoInvent database, so we have everything you could possibly want here, and you can just pull it directly into each process, and you can model it yourself. So that's the big benefit of OpenLCA for me, is that we can model the life cycle of the product with a very granular level of detail, and so it feels like we have a lot more control over the final answer. In comparison with Dayrise, it's putting AI inputs to some values, and it's unclear where some of the data points are coming from. So that's the overall summary of, the differences between OpenLCA and Dayrise. If you had to get my opinion, I would choose OpenLCA for modeling these life cycles of products, mainly because you can also do the cradle to grave. And that was something I was about to get into at the end here. I also wanted to look at what the carbon footprint is of a disposable diaper when you include the disposal and landfill at the end, which is something that Dayrise cannot do. So let's just go here and just see what the difference is. And I already modeled it here, so I'm just going to calculate and run it from here. I will note that Dayrise does have a much better user interface. I'm not a huge fan of OpenLCA. The UI is not great. But going into the results, so we can see here the carbon footprint when you include disposal and landfill of the diapers is around 24.55 kilograms of CO2 for 136 diapers. So if we go back to the other one, we can see it's about 3 kilograms higher. So this just goes to show how important it is to do a cradle to grave assessment in most cases, because you're going to be missing out on a lot of the life cycle impacts if you're not including the disposal and landfill or compost or recycling. So that's another big downside to Dayrise, is that you can't model the disposal and then also the use phase. And we didn't go into reusables here, but if we wanted to model a reusable diaper, we're missing at least 50% of the life cycle impacts of a reusable diaper when we don't consider the use phase, because it's going to be washed and dried, which requires a lot of electricity and increasing its carbon footprint. So that's a very good thing to remember. Now I'll go over everything again at a higher level during the presentation, but I thought this would be a great video to add to the appendix if you were curious about OpenLCA, or if you just wanted to see how we, my experience in comparing the two software platforms. So thank you so much for listening, and I hope this was helpful.